Light gauge steel is a widely used material in the construction of buildings, especially commercial projects. It is characterized by thin sheets of galvanized steel, cold formed into various shapes which replace dimensional lumber for use in the assembly of wall and floor systems. The most common shapes, identified by the acronym STUFFLE, are stud, in the form of a C shape, which is used for the vertical elements of a wall system; track, used as the top and bottom plate of a wall for the studs to attach to; U-channel, which has multiple uses but all relate to wall reinforcement; furring, used for buildup of walls, ceilings, and roofs; and then L-header, which is an L-shaped piece used for the assembly of headers. Now, these materials are referred to as light gauge because of their thickness, which is translated in units of gauge. The industry standard for light gauge metal framing is thicknesses ranging from 12 gauge to 24 gauge. As the gauge number goes down, the material thickness increases. So 12 gauge material would be thicker than 24 gauge material. As the thickness of the material increases, so too does its strength. This is a big advantage when comparing it to dimensional lumber. If we consider the scenario of framing a non-load-bearing demising wall, with dimensional lumber, if we're using 2x4s, the density of that 2x4 remains constant whether it's a load-bearing or a non-load-bearing application. But in this instance, since we're building a non-load-bearing wall, if we use light gauge steel for this wall, now we can use a 22 gauge metal 2x4 stud to frame that wall because it's not required to carry any load. The material is much lighter and easier to handle and work with, and therefore makes it a much more efficient product as compared to using 2x4 dimensional lumber to build that wall. Light gauge steel can also be used for framing load-bearing wall applications, and this is where the heavier gauge material comes into play. Also, with that heavier gauge comes a higher cost for the material, and it's in these applications where the comparison between light gauge metal and wood can start to become a lot closer, and then a greater evaluation is needed to really determine what the appropriate application is. Now, what about quality control? Just as dimensional lumber material is tagged to identify its characteristics, so too is light gauge steel. Understanding this, let's play out a scenario here where you're in charge of quality control on a project and you need to verify the appropriate size material is being used for your project. The plans specify 6-inch 20 gauge studs to be used, and when you check the material on site, what you find is a bunch of letters and numbers but nothing indicating 6-inch 20 gauge. This is a great example of how different industries talk in different languages. The information's there, it's just identified in the manufacturing industry's terminology, and unfortunately, as a construction manager, you're going to be tasked with becoming familiar with many different industry terminologies. So, you might as well start to get used to it. Okay, so that being said, what these markings specify is web dimension, shape, flange dimension, and thickness. Now, you're probably saying, that's great, but that still doesn't tell me anything. So, let's break it down. To start, the 600 refers to the material's width in inches. So the web of this member is 6 inches wide. Let's say it was 6.5 inches wide. Then instead of it being a 600, it would actually be 650. Then we see after the 600 there's an S. That mark indicates that this is for a stud usage, or if it were a J, it would be used for a joist. 162 represents the stud's flange width, and just like the depth, it's measured in 1/100th of an inch. So this flange is 1.62 inches wide, or 1 5/8 inches. The last two numbers represent the thickness of the material being used. So in this case, the 33 represents 0.033 inches, or 33 mils thick, which is 33 hundredths of an inch. So there you go. Now we know how to decipher these codes and we can confirm that we do have the right material. But wait a minute. we still haven't confirmed if this is in fact 18 gauge material. So how do we use this information to determine that? We got to go one step further here. Knowing the thickness in mils, we can take that information and use a conversion table to determine that 33 mils is equivalent to 20 gauge material. Now we can in fact confirm that we do have the right material as specified for the project. Now, I know you may be taking all this in thinking there's no way I'm possibly ever going to remember all this information, and that's okay. What you want to take away from this is a better understanding of a material that is widely used in the industry, and knowledge of how to decipher its coding system for better quality control measures, along with knowledge of common pieces used in light gauge metal framing, and the potential advantages and disadvantages of using this material over that of dimensional lumber. With that, you've got some very powerful tools to be able to do evaluations on different project types to determine the appropriate application for the given project.